Today we're diving into the world of data preprocessing, a crucial step in any data analysis or machine learning project. Before we can extract insights or build predictive models, we need to ensure our data is clean, consistent, and ready for analysis. Data preprocessing is the process that transforms raw data into a usable format, addressing issues like missing values, inconsistencies, and noise. Without this step, even the most advanced algorithms can produce misleading results. In this video, we'll explore why preprocessing is so important and how it sets the foundation for successful data-driven decisions. Let's get started by understanding what data preprocessing really means. Raw data is the initial unprocessed information collected from various sources. It can come from sensors, surveys, transactions, or even social media. This data is often messy, containing errors, duplicates, and irrelevant information. Imagine trying to analyze a spreadsheet filled with typos, missing entries, and inconsistent formats. Without cleaning and organizing this data, any analysis would be unreliable. That's why understanding the nature of raw data is the first step in the preprocessing journey. By recognizing its imperfections, we can better appreciate the need for thorough preparation before any meaningful analysis can take place. Working with raw data, several common issues can arise. These include missing values where some data points are absent, inconsistent formats such as dates written in different styles, and outliers which are values that deviate significantly from the rest. Additionally, duplicate entries and irrelevant information can clutter your dataset, making analysis more challenging. Addressing these problems is essential to ensure the quality and reliability of your results. By identifying and resolving these issues early in the preprocessing stage, you lay the groundwork for accurate and meaningful insights later on. Data preprocessing acts as a filter, transforming raw, messy data into a structured and consistent format. This step is vital because it directly impacts the performance of any subsequent analysis or machine learning model. By cleaning, normalizing, and organizing the data, preprocessing ensures that algorithms can interpret the information correctly. Think of it as preparing ingredients before cooking a meal. Without proper preparation, the final dish may not turn out as expected. Preprocessing is the foundation that supports every successful data project. One of the first steps in preprocessing is data cleaning. This involves identifying and correcting errors, removing duplicates, and handling missing values. For example, if a dataset contains several entries with the same information, these duplicates can skew the results. Similarly, missing values need to be addressed, either by filling them in with reasonable estimates or by removing incomplete records. Data cleaning ensures that the dataset is accurate and ready for further analysis, reducing the risk of biased or incorrect conclusions. Missing data is a common challenge in real-world datasets. There are several strategies to handle this issue. One approach is to fill in missing values using statistical methods such as the mean or median of the available data. Alternatively, you might choose to remove records with too many missing entries. The choice depends on the nature of the data and the goals of your analysis. Properly addressing missing data is crucial for maintaining the integrity of your results and ensuring that your models are not biased by incomplete information. Outliers are data points that differ significantly from other observations. They can result from errors, unusual events, or natural variations. Outliers can distort statistical analyses and lead to misleading conclusions. During preprocessing, it's important to identify and decide how to handle these values. Options include removing them, transforming them, or using robust statistical methods that are less sensitive to outliers. The chosen approach should be based on the context and the impact of outliers on your analysis. Standardization and normalization are techniques used to scale numerical data. Standardization transforms data to have a mean of 0 and a standard deviation of 1, while normalization scales values to a specific range, usually between 0 and 1. These methods are essential when features have different units or scales, as they ensure that each variable contributes equally to the analysis. Without scaling, algorithms might give undue importance to variables with larger values, leading to biased results. Many datasets include categorical variables, such as colors, brands, or countries. These need to be converted into numerical values for most machine learning algorithms to process them. Common techniques include one-hot encoding, which creates binary columns for each category, and label encoding, which assigns a unique number to each category. Proper encoding ensures that algorithms can interpret categorical data correctly, improving the accuracy of your models. Feature engineering involves creating new variables or modifying existing ones to improve the performance of your models. This can include combining features, extracting useful information, or transforming variables into more meaningful representations. Effective feature engineering can reveal hidden patterns and relationships in the data, leading to better predictions and insights. It's a creative process that requires domain knowledge and a deep understanding of the data. As datasets grow in complexity, they often contain many variables, some of which may be redundant or irrelevant. Dimensionality reduction techniques such as principal component analysis (PCA) help simplify the data by reducing the number of features while preserving important information. This not only makes analysis more efficient but also helps prevent overfitting, where models perform well on training data but poorly on new data. Dimensionality reduction is a powerful tool in the preprocessing toolkit. Many projects, data comes from multiple sources, such as databases, spreadsheets, or APIs. Data integration is the process of combining these sources into a single unified dataset. This step involves resolving differences in formats, structures, and naming conventions. Proper integration ensures that all relevant information is available for analysis, providing a comprehensive view of the problem at hand. It's a critical step for projects that rely on diverse data sources. Data transformation involves converting data from one format or structure to another. This can include aggregating data, changing data types, or applying mathematical functions. Transformation helps ensure that the data is in the right shape for analysis or modeling. For example, you might convert timestamps into separate date and time columns or aggregate sales data by month. Effective transformation makes downstream analysis more straightforward and meaningful. Data reduction is about simplifying datasets by reducing their size without losing important information. Techniques include sampling, where a subset of data is selected for analysis, and aggregation, where data is summarized. These methods help manage large datasets, making analysis faster and more efficient. Data reduction is especially important when working with big data, where processing the entire dataset may be impractical. High-quality data is the foundation of reliable analysis and decision-making. Poor data quality can lead to incorrect conclusions, wasted resources, and missed opportunities. Preprocessing plays a vital role in ensuring data quality by addressing errors, inconsistencies, and gaps. Investing time in preprocessing pays off by enabling more accurate models and better business outcomes. Remember, the quality of your results depends on the quality of your data. Machine learning algorithms rely heavily on the quality and structure of input data. While preprocessed data allows models to learn patterns effectively, leading to higher accuracy and better generalization. Conversely, poor preprocessing can introduce noise and bias, reducing model performance. By investing in thorough preprocessing, you set your machine learning projects up for success, ensuring that the models are both robust and reliable. Real-world projects, data preprocessing is often the most time-consuming part of the workflow. Analysts and data scientists spend significant effort cleaning, transforming, and organizing data before any modeling begins. This investment is crucial for achieving reliable results. Real-world data is rarely perfect, so robust preprocessing practices are essential for turning raw information into actionable insight. A variety of tools are available to assist with data preprocessing. Popular programming languages like Python and R offer powerful libraries such as Pandas, NumPy, and scikit-learn. These tools provide functions for cleaning, transforming, and analyzing data efficiently. Choosing the right tools can streamline the preprocessing workflow and help ensure that your data is ready for analysis. Automation can greatly enhance the efficiency of data preprocessing. By using scripts or specialized software, repetitive tasks like cleaning, encoding, and scaling can be performed quickly and consistently. Automation reduces the risk of human error and frees up time for more complex analysis. As data volumes grow, automation becomes increasingly important for maintaining productivity and data quality. Despite its importance, data preprocessing can be challenging. Issues such as incomplete documentation, inconsistent data sources, and evolving requirements can complicate the process. Overcoming these challenges requires careful planning, attention to detail, and a willingness to iterate. By anticipating potential obstacles, you can develop strategies to address them and ensure a smooth preprocessing workflow. Adopting best practices can make data preprocessing more effective. Start by thoroughly understanding your data and its sources. Document each step of the preprocessing workflow, including any assumptions or decisions made. Use version control to track changes and ensure reproducibility. Regularly validate your results to catch errors early. Following these practices helps maintain data integrity and supports reliable analysis. Documentation is a key aspect of data preprocessing. By keeping detailed records of each transformation, cleaning step, and decision, you create a transparent and reproducible workflow. Good documentation makes it easier to revisit and update your process as new data becomes available or requirements change. It also facilitates collaboration with other team members, ensuring everyone is on the same page. Reproducibility means that others can follow your preprocessing steps and achieve the same results. This is essential for scientific research and collaborative projects. Using scripts, version control, and clear documentation helps ensure that your workflow is reproducible. Reproducibility builds trust in your results and makes it easier to share your work with others. Data preprocessing is rarely a one-time task. As new data becomes available or project requirements evolve, you may need to revisit and update your preprocessing steps. This iterative approach allows you to continuously improve data quality and adapt to changing needs. Embracing iteration ensures that your analysis remains relevant and accurate over time. Collaboration is often necessary in large data projects. Multiple team members may contribute to different parts of the preprocessing workflow. Clear communication, shared documentation, and standardized processes help ensure that everyone is aligned. Collaboration not only speeds up the workflow but also brings diverse perspectives, leading to better solutions. Ethics play a significant role in data preprocessing. It's important to ensure that data is collected and processed in a way that respects privacy and avoids bias. Removing sensitive information, anonymizing data, and being transparent about preprocessing steps are all part of ethical data handling. Responsible preprocessing helps build trust and protects the rights of individuals represented in the data. Legal regulations such as GDPR or HIPAA may impact how data is preprocessed. These laws set standards for data privacy, security, and consent. Ensuring compliance is essential to avoid legal risks and protect the interests of data subjects. Always be aware of relevant regulations and incorporate compliance checks into your preprocessing workflow. Data security is a critical concern during preprocessing. Sensitive information must be protected from unauthorized access or breaches. Implementing strong security measures such as encryption and access controls helps safeguard data throughout the preprocessing workflow. Security should be a priority at every stage from data collection to final analysis. Data presents unique challenges for preprocessing. The sheer volume, variety, and velocity of data require scalable tools and efficient workflows. Distributed computing frameworks such as Apache Spark can process large datasets quickly. Adapting preprocessing techniques to handle big data ensures that insights can be extracted from even the largest and most complex datasets. Real-time data, such as streaming sensor readings or live social media feeds, requires special preprocessing techniques. Data must be cleaned, transformed, and analyzed on the fly. Real-time preprocessing enables immediate insights and rapid decision-making, which is essential in applications like fraud detection or monitoring systems. Different industries and domains have unique preprocessing requirements. For example, healthcare data may need to comply with strict privacy regulations, while financial data requires rigorous validation to prevent fraud. Understanding the specific needs of your domain helps tailor preprocessing steps to ensure data is both accurate and compliant. After preprocessing, it's important to evaluate the effectiveness of your steps. This can involve checking for remaining errors, assessing data quality, and validating that transformations have been applied correctly. Regular evaluation ensures that your data is truly ready for analysis and helps identify areas for improvement in your workflow. Feedback loops are essential for continuous improvement in preprocessing. By regularly reviewing results and incorporating feedback, you can refine your workflow and address new challenges as they arise. Feedback from stakeholders, domain experts, and end users helps ensure that preprocessing meets the needs of the project. Visualization tools can aid in the preprocessing process by revealing patterns, outliers, and errors in the data. Charts, graphs, and plots make it easier to understand the structure and quality of your dataset. Visualization not only helps identify issues but also communicates findings to others, supporting collaboration and decision-making. Text data such as emails or social media posts requires specialized preprocessing techniques. This can include removing stop words, stemming or lemmatizing words, and converting text to numerical representations. Proper preprocessing of text data enables more accurate analysis and supports applications like sentiment analysis or natural language processing. Image data also requires unique preprocessing steps. This can involve resizing images, normalizing pixel values, and augmenting data with transformations like rotation or flipping. Proper preprocessing ensures that image data is consistent and ready for analysis by computer vision algorithms, improving model performance and accuracy. Time series data, such as stock prices or sensor readings, presents unique challenges. Preprocessing steps may include handling missing timestamps, resampling data, and removing trends or seasonality. Properly prepared time series data enables accurate forecasting and analysis, supporting applications in finance, engineering, and more. Structured data like spreadsheets or databases is organized into rows and columns. Preprocessing structured data often involves cleaning, transforming, and validating each field. Ensuring consistency and accuracy in structured data is essential for reliable analysis and modeling. Unstructured data, such as emails, images, or audio files, lacks a predefined format. Preprocessing unstructured data involves extracting relevant information and converting it into a structured form for analysis. Techniques vary depending on the data type, but the goal is always to make the data usable for downstream tasks. Multimodal data combines different types such as text, images, and audio. Preprocessing multimodal data requires handling each type appropriately and integrating them into a unified format. This enables comprehensive analysis and supports advanced applications like multimedia search or cross-modal retrieval. Monitoring preprocessing pipelines ensures that data is processed correctly and efficiently. Automated checks can detect errors, bottlenecks, or changes in data quality. Regular monitoring helps maintain high standards and quickly addresses any issues that arise during preprocessing. As data volumes grow, scaling preprocessing workflows becomes essential. This can involve parallel processing, distributed computing, or cloud-based solutions. Scalable workflows ensure that preprocessing remains efficient and effective, even as datasets become larger and more complex. Continuous improvement is key to successful data preprocessing. By regularly reviewing and updating your workflow, you can adapt to new challenges and ensure ongoing data quality. Embracing a mindset of continuous learning and improvement helps keep your preprocessing practices up to date and effective. Let's recap what we've covered. Data preprocessing is an essential step in any data project, transforming raw data into a clean, consistent, and usable format. It involves cleaning, transforming, integrating, and validating data to ensure quality and reliability. Effective preprocessing supports accurate analysis, robust models, and better decision-making. By investing time and effort in preprocessing, you lay the foundation for success in any data-driven endeavor. Conclusion: understanding and prioritizing data preprocessing is crucial for anyone working with data. Whether you're a data scientist, analyst, or business leader, recognizing the importance of this step can make all the difference in your projects. Remember, great results start with great data. By mastering preprocessing techniques, you empower yourself to unlock the full potential of your data and drive meaningful outcomes.